Okay, so this is a coding question. It's mentioned that this sentence peacock is designated as the national bird of India is coded as follows. So there are corresponding word and new numbers code. You can count the number of letters. You'll easily identify that. So peacock has 7 letters and 5688 999 has 7 letters. But when you're reading the premise for the first time, if you're not read the points as of now, so one thing will should automatically strike you is that not all the letters will have a different code, because if you check peacock itself, peacock has only C repeated, right? The letter C is repeated in peacock, but here in the code you're finding there is 5688 999. So there are like a lot of repetitions in this code itself. So there might be multiple letter having the same code, and that will be obvious once you read the additional information. So let us do that. The coding scheme has the following rules. The scheme is case insensitive. So if you know that, that's fine. Otherwise, as CAT does, it will always explain these technical words. So it tells you that does not distinguish between the uppercase and lowercase letter. So if P is written in capital or P is written in small letter, it doesn't matter. It will have the same code. I written capital, I written small, it will have the same code, and so on. So you have case insensitivity. Okay, great. So that is fine. No need to record that. Point number two is important. Point number two tells us that each letter has a unique code. So a letter has a unique code. It doesn't say a letter has a distinct code. So it has a unique code. So for each letter, you will have one code, which is a single digit among this 1 to 9. So zero is not used. So that is mentioned. You can see that in the coding also. And it's obvious from point number two now that only the digits 1 to 9 are used. Now, third point is the most important one. Third point tells us that digit 9 codes 2 letters. So, as I was saying earlier, there will be multiple letters with the same digit as the code. So, digit 9 codes 2 letters and every other digit codes 3 letters. So, this should be mathematically justifiable for you. So, you have, apart from 9, you have 8 other digits allowed, 1 to 8. 0 is not an option. So every other letter is, or rather, the digit is in coding for or coded. Sorry, code for three different letters, right? So 8 into 3 is 24 letters, and the digit 9 is used for 2 letters. So that is two more letters. So that is 26 letters, right? So that covers all the letters in this alphabet. So not all the letters in the alphabet are used in this particular sentence. So we won't be able to justify all the codes here. So, for example, Z, W, Y, these are pretty obvious are missing. And a lot of others are missing. V is missing. So a lot of others are missing, right? So only the ones which are given, we can figure it out. So now the code for a word is constructed by arranging the digits corresponding to its letters in a non-decreasing sequence. So this now should make it obvious that this 5688 999 is not corresponding. So it's not that P is 5, E is 6, A is 8, C is 8. It's not that. You have taken the code taken the code for each letter of this word and then arranged it in a non-decreasing sequence. So 5688 999, you can see that it's a ascending order, right? It's not decreasing order. It's a non-decreasing order. So that is what is done. So we are going to use two things to solve this out. One is I'm going to use this structure, this digits here. Let me just take this off. Let me just build this table once. Yeah, so each of these digits are going to have, 1 to 8, that is. 1 to 8, every digit will have 3 letters associated with it. So we will fill maximum of 3 for each of them. And for 9, we will have 2 letters, right? So I can even put some blanks to indicate that these things, but I'm not doing that. So as we get the codes, we will surely, as we surely get a code, we'll put it in this particular table. So this will be our solving part. And the association part, I have to do it in a different way. So how do I do it? So I'll just develop another table. So in that case, what I'll do is I'll take the code as it is. So for example, let me show you with this peacock one. And when I'm writing this peacock, I'll just keep the repeated letters. So C is repeated. So just spell it out. I will look at this part and just spell it out and keep the couple of C's together. So when I'm looking at this, I'll identify that this couple of C has to be having the same code, right? So from here we now know that this couple of C has this two 8 as an option or 2 9 as an option. So C has to be 8 or 9, right? So that should be some leading point. So what I'm going to do is I'm going to develop this table. So let's do that first. Okay, we can start the analysis from a lot of different points here. So this is the table I was talking about. Now it should be pretty obvious in the repetition part. So I'll hit on the repetitions first. That might give us a bit of clue. You might think in this way that IS and AS has to have something common. So you can start with this S itself. I mean, S is a pretty obvious one, right? This has to be 5. You can hit on those kind of things. But let me first hit on the couples here. So with whichever repetitions that we find. So we are finding these repetitions here, finding it here and here. So there are two repetitions here. D and E are both repeated. So this is telling me that D and E has to be from 5 and 5 or 6. So one is 5, another is 6. But as of now, I don't know. So let's not use that. C is also a couple of options, 8 and 9. So I'm trying to hit a definite one. Let's look at this, N and A. Now this is interesting, right? See, N and A, there is only 6 6 and 6 6 repeated, right? So this implies that N and A should be both 6. This is pretty obvious. So if I do that, let me show you how I'm going to solve this. So I'm going to first put N and A here with 6. N and A goes here. And wherever I have N and A, I'm going to cancel out the equal amount of 6 from that code. So here I have couple of N gone. So couple of 6 gone. Couple of A gone. Couple of 6 gone. And from the rest of it as well. So A goes from here and 6 goes from here. A goes here and one of the 6s goes here. So as I was saying, I mean, this another 6 should be something else. In this case, you will find that N is that 6. So this is also going off. So this A goes here, 6 goes. Again, where else do we have N and A? Yeah, so we have here N and A. So a couple of 6s goes. So 6 is allocated. So N and A are allocated. Let us put it that way. Now, which are the obvious ones now? So this should be pretty obvious right away. So S should be 5. So let us take off this S5 and write it here. Let me write it from leftwards because there are 3 letters in each of them. And everywhere else, wherever we find S, I'm going to cancel out the 5. So S goes, 5 goes. I is obvious from here, but let's wait for that. Let us first carefully take these things off. Otherwise, that will be a problem later on. So S goes, 5 goes. What else do we have? S. Nowhere else S is there, right? So that is it. So this is taken. So now I is pretty obvious from the second code. So I takes up 3. So I goes here. What else do we have? I designated has a I. This goes. National has a I. Bird has a I. I mean, bird already has a I. Anyhow, couple of I's, couple of 3's. Okay, so that is it. And then we are getting this D, right? So the D is 1. So D is taking up 1. So let us do that. D goes here. Let's take off the D's here. So this here, first code doesn't have a D. Third one has D. Let's take off these couple of 1's. This D is 1. Okay, sorry. I did something wrong. Just 1 second. One second. Okay, no, this was fine. Okay, I remember. My bad. I took off I from here and I took off 3 and 1 for some reason. Oh, I took that D first. Okay, I got confused. I mean, why did I scratch off D? Okay, I should not have done from the downside. Just be a little careful in this case. Okay, let me verify here. D's are taken off. Everything is gone. Yeah, so D is 3. So that is done. Where are the definite ones now? Where are the definite ones? Okay, there are a couple of definite things that we can figure out. Rather, one definite one. I mean, here there is still that problem. It could be 8 or 9 C. That is still a problem. But E, there are a couple of E's in this, and this has to be a couple of 5's, right? So we are getting 2 things straight away. So we are getting E is 5, and obviously then T is 8, right? So no, T can be 7 also. Okay, G and T are remaining. So let's not do that. Okay, E is 5 for sure. So let us put that. Let's put an E here. And let us strike off all the E's that we have. So E is 5. That's it. Okay, what else? Now let us come into some comparison. If I look at this designated one and these two words, there is 7-8 remaining and 4-8 remaining. So T has to be the same letter, right? So T has to be same letter. So T has to be 8. I meant to say T has to be the same digit. So T has to be 8, right? So T taken off 8 and 8 is gone. So T is 8. Let's allocate that. Okay. Here also T is gone. Nowhere else there is a T. And immediately you will find that G has to be the remaining one. G has to be 7, right? So G is 7. Do we have a G anywhere else? No, right. So that's all we have. Okay, now coming to the remaining bit. H is 4, by the way. H is 4, but the thing is, H is taking only one of the words. It's nowhere else. So H is 4. So what else do we have? Let me just try to clean this off a bit as far as possible. Okay, E was 5. I forgot to strike this off. What else do we have? I'm just verifying as of now. This part you have to do a little carefully. That is what I'm trying to do. Okay. Now that comparison thing that I was talking about. Let us look at this one, the CC, this OL, and this off. All of these three has O in common, right? And if you look at the codes, this has 8 and 9 remaining. This has 1 and 9 remaining. This 1 is remaining, by the way, that is not striked off. And this has 7 and 9 remaining. So the only thing that is common between all of them is 9. So I can say O is definitely 9. So O is 9. One of the 9 goes from here. 9 goes. 9 goes. So L and F we can immediately figure out, right? L has to be 1 and F has to be 7. So these two are definitely figured out. Now there is one doubt here, right? O has taken up 9, but in this code we have couple of 8s and couple of 9s remaining, isn't it? Now understand this. This word that we have couple of C's remaining and one P and one K remaining, right? So the 9 that we have, I'm focusing on the 9 because if you remember, 9 can have only 2 letters. In as code. So you cannot have both P as well as K, because if C is allocated to 8, then both P and K has to be allocated to 9, right? According to the code of this word. That if you do this, then P and K will both go to this particular cell. O is already in that cell, so you cannot have 3 letters in for 9, right? So it has to be C as 9, and P and K as 8. So let us do that quickly. So C is 9. Let's put that, and P and K are both 8s. So P and K are both 8s. What else are left? Only this thing. And there is no way to actually discriminate, right? So B and R could be either of 3 or 4, isn't it? So it will be B or D here, and this will be D or B here. So this is what we have for this code. Nothing else can be figured out because everything is solved now. So let us now get into the questions. This is B or R, by the way, before we get into questions. B and R was remaining, not B and D. B and R is among 3 or 4. So this is B or R, and this is R or B. Yeah. Now let us get into questions. Okay. So now let us try these questions. So I would just require this thing to figure it out. 25 is asking for what best can be concluded about the code for letter L. So L is definitely 1, right? So L is having a code of 1. So that is definite. What best can be concluded about the code for letter B? Now B has a couple of options. So B or R will switch between this 3 or 4. We cannot conclude that. So this is either 3 or 4. For how many digits can the complete list of letters associated with that digit be identified? It's not that how many letters are associated with the digits that we know. It's the other way around. So if you, again, let's recall that for 1 to 8, each will have 3 letters associated, right? And this one will have 2 letters associated. So first of all, we know both the letters for 9. So this is done. 8 has 3 letters. This is done. None of the remaining are done, right? either partially missing, or in case of 2 it is completely missing. So we need to know the third one for 1, 3, 4, 5, 6, and 7. Even for 3 and 4 we don't even know exactly which is B, which is R. So only 2 of the digits we know exactly the set of letters which they are indicating. So the answer for this is option A. And the last one is asking for which set of letters cannot be coded with the same digit. So if you check this with the options, because which set of letters, obviously we have to check from the options. So SUV, now SUV is not possible, right? Because in 5, S and E are allocated together, already there, right? So you cannot have U and V also allocated with S, because if you do that, then 5 will be representing 4 different letters, which is not allowed. So SUV is the answer. We are looking for cannot be. The remaining you can check X, Y, Z. I mean, they can completely go inside 2. 2 is fully blank. SEZ is possible. I mean, with S and E, you get Z. And IBM, I mean, IB, you can have I and B here and then M with it. So they can be, right. We are not looking for a definitely true kind of thing. We are looking for a definitely false kind of thing. So option A is the answer here. And that cannot be true. So again, I would say this is definitely an easy set, but a little calculative side, because you have to be careful also. So be a little cautious while solving that, canceling out those things. So you might have seen while I was solving, I was in between cross checking also. So I know that these kind of mistakes happen typically. I mean, even I can make those mistakes. So it's good to be careful and verify in between also sometimes, when you have a little bit of gut feeling that a lot of things are done, a lot of things are cancelled out, you might miss out something. So be a little careful in the latter stage while you are cancelling out and all. So that's it for this particular set. I mean, solving time should not be a too much of this thing. I mean, when I said calculative, I mean not from numerical analysis point of view, just time consuming. Let's put it in that way. A little bit time consuming. But if that was not the case, then this is a very easy set to solve. I mean, you would have done it in 3-4 minutes maybe. So CAT will never give you a set like that, which everybody can solve in 3 to 4 minutes. So this would be somewhere around 6 to 8 minutes, ideal time to solve this set. There's questions, as you can see. I mean, it's very easily done, right? I mean, the time taken for marking all the 4 questions would be roughly 1 minute. So that's it for this set. Hope you liked it. Thank you for joining in.